All right, welcome to this video on writing parallel and perpendicular proofs. In the last video, we actually went over some common rules that are used in those proofs, and now we're actually going to write a few proofs together that involve parallel and perpendicular lines. Okay, so the first proof we're going to write as a fill in the blank, because this is our first unit on proofs, is a proof of the corresponding angles theorem. And I do want to stress to you that proofs of corresponding alternate interior and alternate exterior angles theorems are going to be done using the same side interior angles postulate, because all of these begin with parallel lines, and the same side interior angles is a postulate from all the way from Euclid's fifth postulate that we reviewed in class when we read the original wording and translated it into the more modern wording. That also starts with lines being parallel. But if we're going to do a converse proof of one of the converse theorems, we're going to use the converse of the same side interior angles postulate. All right, so our proof of the corresponding angles theorem. If parallel lines are cut by a transversal, then corresponding angles are congruent. So if we remember, the hypothesis of the statement is what leads to our given information. So we have to be given that the lines are parallel and cut by a transversal, which is why I said A is parallel to B, and it's cut by transversal T here. And then the prove comes from the conclusion of the statement. We are going to try to prove that a set of corresponding angles is congruent. And so it looks like I'm going to use 2 and 6. Okay, I recommend when you're doing a proof with angles, don't number all of the angles in the picture, just number the ones you're going to use and maybe as you need them. So our first step is always a given. All right, step 2. Angle 2 is a linear pair with angle 4. Well, if I look at angle 2 and I look at angle 4, they are adjacent angles that make a straight line, so that's the definition of a linear pair. Okay, and I will be abbreviating linear pair with LP, okay? Now, next we're saying, okay, 2 is a linear pair with 4, which means 2 supplements 4. Well, the linear pair theorem says that linear pair angles are supplementary. So linear pair theorem. You can also call that the supplements theorem. A lot of books call it that. I don't care which name you give it, because as the teacher, I should know them both, so I can give you full credit for either one. Then next, we're going to look at angle 6 and angle 4, and we can see in the picture, those are same side interior angles, so that's going to be definition of same side interior angles. And then it says they are supplementary. Well, we learned by the same side interior angles postulate that if the lines are parallel, same side interior angles are supplementary. Same side interior angles postulate. And then finally, 2 is congruent to 6. Well, you can see here, we have linked 2 to 4 by saying they're supplementary, and 6 to 4 by saying they are supplementary. So now I can say that 2 is congruent to 6 by the congruent, because the congruent supplements theorem says 2 angles that supplement the same angle have to be equal to each other. Congruent supplements theorem. All right, so both of these came together to give us that. Okay, let's do another proof. We're going to prove the transitivity of parallel lines. Okay, so we're going to say, okay, we've already proven all the other 8 rules. Actually, it's 6 because 2 of them are postulate about parallel lines and transversal angles. So they are all valid to use in this one. Okay. Oh, I know why it's 8, because we have the perpendicular transversal theorem and its converse. All right, so we are going to prove that if 2 lines are parallel to the same line, they are parallel to each other. We are given that P is parallel to Q, so I'll mark P and Q parallel. We are also given that P is parallel to R. So we want to link together that Q is parallel to R. So I'm going to write given for the first reason. Okay, and I'm going to use some angles to do it. Alternate exterior angles theorem because P is parallel to Q. So if I'm looking at P and Q, these are alternate exterior angles. So I can say angle 1 is congruent to angle 2 for that reason. All right, next we have angle 1 is congruent to angle 3. Well, if I look at angle 1 and angle 3 and P being parallel to R, they are corresponding angles. So it's the corresponding angles theorem that says if the lines are parallel with the blue arrows as is marked up there, then the corresponding angles must be equal. So if I look at what I have here, I'm trying to prove Q is parallel to R. And right now I have angle 1 is congruent to angle 2, angle 1 is congruent to angle 3, which means angle 2 and 3 have to be congruent by transitive. All right, and we could say property of congruence, but I'm happy if you write transitive. Technically, it could be substitution. Remember our big discussion in class about how all transitive is substitution, but not all substitution is transitive. And we did an example to show that. All right, so if 2 is now congruent to 3 and they're alternate interior angles and they're congruent, that means these lines have to be parallel, but the converse of the alternate interior angles theorem. Okay, so now we have proven that parallel lines, are transitive. All right, our last proof is a really simple one, and it's one that's not even a theorem. It's just practicing doing a random proof that has been made up. This picture came online with all the angles numbered, but we don't need them all. So I'm just going to, kind of highlight the ones that we do want to focus on using. So I can see an angle 10, a 14, and an 8 all in here marked up. 10, 14, and 8. So we're going to focus on those 3 angles and only add other ones if we need to. We have N is parallel to M, so I'll mark those parallel. And we have that A is parallel to B. So both sets of lines are parallel, which means all 16 angles in the picture are going to be one of 2 angle measures. Here we go. Why is angle 10 congruent to angle 14? Here's angle 10, here's angle 14, okay? If you look at these 2 lines, and this being a transversal, they are corresponding angles. So we can write the corresponding angles theorem. Remember, we talked about abbreviating. You could say parallel lines imply corresponding angles congruent. You can also abbreviate it that way. So I don't care which way you write it. All right, so now we got 10, 14. Now let's look at the next step, which says angle 14 is congruent to angle 8. So if we look at that picture, here's angle 14, here's angle 8. So the transversal linking those angles is M, and the lines are parallel. So 14 and 8 are alternate exterior angles. So that is the alternate exterior angles theorem. Or you can abbreviate as parallel lines imply, I'll do it with capital, alternate exterior angles congruent. You can abbreviate that way if you like. So I've got 10 congruent to 14 and 14 congruent to 8. That means that angle 10 is going to be congruent to 8 by transitive or substitution. Property of congruence. And that is the end of that proof. So this is the end of our lesson on parallel lines, perpendicular lines, and the proofs that are involved in them. We're going to be getting ready for our Unit 2 summative on proofs, and then we will be coming back for Unit 3 where we start doing transformations.